Hello everyone, and listen up. Today, we'll be doing a video on this guy here, behind that pile of cables. For those who don't know, this is an inverter BMS. Today, I'll show you how to connect it to the ENSolarX device, i.e., this device. How to configure it, how to make it work. And it does work. So, check out the video. Okay, so let me start by telling you what we'll be connecting this BMS to. This is the ENSolarX device. This is the device we can connect. As you can see, it's connected to the inverter with this cable here. This device is connected to the BMS with another cable. And this device, let me turn it on my phone and I'll show you. This device gives us results like this on our phone. So we see some statistics, we see data, I'm not sure if it's clear. We see information from the inverter, and at the bottom we see all the data from the BMS. We can even connect more of these devices, and as you can see, everything is available via Wi-Fi from anywhere in the world. We can see what's happening with our energy storage, our inverter, and our off-grid in general. And this is, so to speak, a throw-in on this one, because generally, with such an installation at home, you'd want to know what's happening with all that lithium in the house. So maybe, let's start by taking a look at this device. Earlier, JK BMSs had a slightly different connection because they had a small plug on their output marked GPS, and this device was a UART output, i.e. at logical levels, the so-called TTL. Here, however, we have a slightly different output because we don't have a UART at 3.3V but an RS485. Basically, from a digital logic perspective, it's the same, except we need a converter, meaning from UART to RS485. See, this converter is hanging here on a spider. We can buy one online for pennies and connect it as follows. See, I'll explain it here. We have signals here on this converter. We have the ENSolar. The wires go like this from the left. There's yellow, white, and red. So yellow is ground, the first one from the left. The second one from the left is RX. The third one from the left is TX. And the fourth one from the left, meaning the first one from the right, is positive 3.3V. So we connect it as shown here. From the top, I don't know if you can see the wire colors, they go like this. 3 wires go to the ENSolarX, but you can see, the fourth black one is the power supply. It needs 3.3V. We need to supply 3.3V to this converter. You can supply it from an external power supply, of course, to ground and to the black wire. Just don't confuse it, because the black one usually means ground, but in this case, because it's the cable that came with this converter, it might be a bit confusing. The black one is the power supply in this case, but in our case it might be different. So anyway, the first one on the right goes to this converter, if we're talking about this converter. Let's go somewhere. Here we can, I just took it from inside the ENSolar, it's 3.3V. And you can either use an external source there or from it, because it needs some. It has a very low current, so we can easily take it from the ENSolar to power this converter. On the other hand, here we have an RS485 output, or maybe an RS485 input. RS485 only requires 2 wires. There are 3 connectors here. The third one is sort of a ground wire, or ground wire. Call it whatever you like. But we only need 2, B and A. We connect B to B of our BMS and A to A. It's connected like this, so I don't know if you can see it clearly. The white wire is to B, the red one on the right to A. I'll show you how it's done in the BMS in a moment. You might not see it, but the first one, the white one, when I hold this plug, the first one from the left is white, the second one from the left is red. And those 2 wires are all we need to communicate with this device. Of course, we connect it to the input, the first one from the diodes, because it's an RS485 communication input, used for communication with a computer, while the other ones are used for communication in parallel modes, etc. You can't connect via those inputs either. A very important thing, this device connects via RS485. And as you know, RS485 requires an address. The address of this device must be address 0. We set the address here with these switches. All 4 must be off. Off, meaning everything is set to 0, meaning address 0. As you can see here, this is very important. And now, one more thing. because we need to do something in our BMS, i.e., in the ODK application. Let's go into the settings and see that at the bottom, there's something like, first, the device address. The device address must be 0, just like we set it to 0 there. And another very important thing, here's something called the UART1 protocol number. Look, UART1 is the UART we connected to. UART1 is the protocol we connected to. UART1 is supposed to be 0. I need to enter a password. I'll show you what other protocols there are. We go in, and we also have these protocols in the protocol. But we're using this 4G GPS Remote Modal Common Protocol. And we need to select this protocol to set up communication with our ENSolarX device. And as you can see, look, the data from the BMS, it's not the BMS, it's the BMS. We have all the data here, nicely. It's still unformatted, and so on. But we have all the data from the individual BMSs, all the data matches, and so on. Communication in the options. We have the parameters here. I'm also reading the key parameters from this BMS. You can control it remotely, as usual. So let me know if you have such a BMS. If you have an energy storage system with this BMS, how do you manage to do it? Because there are so many Chinese storage systems with these BMSs now. Did you manage to connect it? How is it working for you? And are you perhaps having any problems? Share your thoughts there. Leave a comment. You can even subscribe to this channel. I'm not trying to stop anyone. If anyone wants to, I'm saying it as a like for this channel. So, connect it. Don't be afraid. This device works with this SolarX device. As you can see, it supports it. So that's it, I think. Next time. And I won't say what next time. Or maybe I will. And next time, it's just for you. Next video, we'll make one like this. Because all these inverters in general, as you know, they're for themselves. Even if we're connected to the grid, this inverter is a backup. They're for us. Even when the storage is full, they always consume a little of our grid. They kind of consume. And in the next video, we'll disconnect the grid at the storage's charge level, above a certain percentage. Using automatic input cutoff, we'll automatically disconnect it from the grid, so it simply doesn't consume our grid, not electricity from the grid, because it's within limits. I don't know about yours, but for me, it's around 30 PLN. I lose money every month on this inverter consumption, which I draw from the grid. And all those Chinese, as far as I know, they all have this exact condition. So we'll be solving this problem here, and using this ENSolarX device, we'll be connecting a relay, which will disconnect us from the mains. So if you're interested, hit the bell to let us know for sure. That's all. If you have any questions, post them in the comments. We can hang a monitor like that somewhere, and we can see what's going on in our installation. Here you go. This camera is kind of dark at night. Greetings to all off-grid, on-grid, etc. fans. And see you in the next videos. Take care. Best regards. Bye.